This is Bob Capetta, and this is another lesson on Venn diagrams. So we want to start by constructing Venn diagrams. So recall what we typically have. We have a rectangle to define our universal set. And we're going to focus on Venn diagrams with two sets this time. So this is set A, and this is set B. And there are four regions. Region 1, that part in A that is not in B. Region 2, the part that is in both A and B. Region 3, which is in B but not in A. And region 4, which I sometimes call outer space. So our goal in this lesson is to construct Venn diagrams. So construct a Venn diagram that represents A intersect B. So what portion of that Venn diagram represents A intersect B? Now, I think that's one we could think through immediately and just go ahead and construct it. Right? Here's A, here's B. Universal set is the entire rectangle. A intersect B is this section right here. That's what we get. So that's just region 2. That's just region 2. If instead I wanted to get A union B, which is either in A or B or both, what will that look like? And again, I think this is one that we can just sort of think through and draw in immediately. So here's A, here's B. And the universal set, of course, is the whole thing. What regions are either in A or in B or both? That's what the union represents. That's this piece, that's this piece, and that's that piece. But they can get a little bit more interesting than that. Can get a little bit more interesting than that. So let's say I want to construct a Venn diagram for a complement. So that's the stuff that is not in A. So if that's my goal, to get A complement, or if you prefer A with a little c, I want to get A complement. What are the regions that are not in A? So this is A, this is B. Region 1 and region 2 are in A, so the stuff that's not in A would be what? Would be here. That's not in A, and here, outer space. So those would be the regions that are not in A, and similarly, if I wanted not in B, again, universal set, we draw our region. Here's A, here's B. Universal set. What's not in B? What's not in B? This portion and this portion. But friends, it gets harder. You can always ask more complicated sort of things. So I want to give you a strategy to enable you to do that. So for our next goal, we want to get not in A or not in B. What will that be? So we're going to take a look at that. A complement, union B complement. So we're going to look at next. A complement, union B complement. So let's build a strategy for this. How am I going to do that? We're going to label our four regions again. So we have A, we have B, we have universal set. We have region 1, region 2, region 3, and region 4 is outer space. So I'm going to give you a preview on this notion of truth tables that we will be working with in the logic section. So I have region 1, region 2, region 3, region 4. So A is regions 1 and regions 2. So region 1, yes for A. Region 2, yes for A. Region 3, no for A. Region 4, no for A. How about B? Which regions does B show up in? B shows up in 2 and 3. So region 2, yes for B. Region 3, yes for B. But region 1 is a no for B, and region 4 is a no for B. Now I'm going to look at A complement. Remember, if it's not in A, is it true that region 1 is not in A? Well, region 1 is a yes, so it's a no for not in A. Region 2 is a yes, so it's a no for not in A. Region 3, not in A, which makes it a yes for A complement. Region 4, not in A, makes it a yes for A complement. Notice, if you're a yes, become a no. If you're a no, become a yes to go from A to A complement. Same argument for B complement. So next up, we'll do B complement. The no's become yeses. Not in B, region 1. No becomes a yes, yes becomes a no. Yes becomes a no, and no becomes a yes. And how do I finish this? The last thing I want is I want A complement or B complement. A complement or, union means or. It's true in one or the other or both. Is this true in one or the other or both? Yes, it's true in that one. That makes it yes. Is this true in one or the other or both? Nope. Is this true in one or the other or both? Yes. Is this true in one or the other or both? Yes. So I shade region 1, region 3, and region 4. Wherever it's yes, that's where I'm going to shade. So let's look at that. We'll go ahead and draw in A and draw in B. So region 1 gets shaded in. Region 1 is here. Region 3 gets shaded in, which is here. And region 4 gets shaded in, which is all the way out there. So that was A complement or B complement. Let's take a look at another one sort of that regard. This time, I will look at A union B complement. So my goal is, again, to construct a Venn diagram for A union B complement. Maybe you can think through this directly. That's fine if you can. I prefer to use the regions and do the analysis. So here's A, here's B. There's A, there's B. Again, A consists of region 1 and region 2. B consists of region 2 and region 3. Region 4 is outer space. So we want to figure out, how do I shade A union B complement? How am I going to do that? What is my strategy going to be? Well, let's take a look. So again, region 1, region 2, region 3, region 4. A consists of region 1 and region 2, yes, yes. 3 and 4, no, no. B consists of region 2 and region 3, yes, yes, 2 and 3, no, no on the others. Now I need A union B, A or B, A or B, and one or the other or both. One or the other or both, yes. One or the other or both, yes. One or the other or both, yes. One or the other or both, no, 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 no. But now I've got to take the complement of that. So I have my A union B column. I need A union B complement. So you know how complement works. Yes becomes no, no becomes yes. Or you're not in A union B. What is not in A union B? This one. That's the only one that is not in A union B. So all the others would be no. So if I'm constructing a Venn diagram for A union B complement, I am just shading which region? The only yes is region 4. So let's quickly draw that. That's A That's B, of course, universal set, as always. Region 4 is just outer space. So we will shade in the outer space. And that's going to be our A union B complement. And let's do one more. Let's do A intersect B complement this way. Watch your order of operations. That's going to be important as well. So A intersect B complement, just to make sure that you're not thinking it's the complement of A intersect B. So A intersect B complement is what we want to do here. So again, we are going to do what? Here's A, here's B. We have our 4 regions, region 1, region 2, region 3, and region 4. We're going to make our little table and see how that behaves. So region 1, region 2, region 3, region 4. Okay, A is region 1 and region 2. Yes, yes. No, no. B is region 2 and region 3. Yes, yes. And 2 and 3. No, no on the others. That's B. How about B complement? What is B complement? Not in B. So no's become yes. Who's not in B? This one's not in B. That one's not in B. So that's B complement. But I need B complement and A. So let me draw A just so I can see it right next to it. A is Y, Y, N, N. So I finish this off with what? With A and B complement. A intersect B complement. It's got to be in both. It's got to be in both for me to graph it, for me to shade it. A and B, is it in both? Yes and yes, yes it is. In both, no. In both, no. In both, no. So the only region I shade for A intersect B complement is just region 1. And maybe you could have thought that directly. So let's look at this. So here's A, here's B, universal set. The only region I'm shading is region 1. Again, here's A, B in my picture up here. Region 1 is out here. Is that obvious that this region is in A and it's not in B? I mean, maybe. Maybe you can think it through directly to go ahead and get there. Okay, there's one last concept I want to look at, which is how do we decide the number of items in each set? I hope it's obvious. If we look at the Venn diagram, here's A, here's B. Again, this is region 1. This is region 2. This is region 3. I am interested in the number of items, the cardinal number in A union B. Now, that would simply be what? The number of items in region 1 plus the number of items in region 2 plus the number of items in region 3. Because again, we know A union B is those 3 regions, in A or B or both. Now, what are the number of items in region A? That's 1 and 2. That's the number in 1 plus the number in 2. How about the number of items in region in B, in set B? That's the number of 2 plus the number in 3. So you'll notice if I add them together, the number of A plus the number of B, I get 1, 2 is there twice, and then 3 is there once. So equals number in region 1 plus number in region 2 plus number in region 2 plus number in region 3. So that's a problem. It's not 1, 2, 3. That's there an extra time. So what that does is that indicates to us what our rule should be. We've got to throw out the overlap. So here's our rule. The number of items in A union B is the number of items in A, that's region 1 and region 2, plus the number of items in B, that's region 2 and region 3, but region 2 has been counted twice. So subtract off that extra region 2, and region 2 is A and B. So the number of items in A union B is the number in A plus the number in B minus the number of A and B. So let's take a look at a question that uses this rule. We're going to look at students taking college classes. So according to our rules for the upcoming fall semester, we have 75 students. 75 students enrolled in liberal arts math. So we look at all the liberal arts math sections. Maybe there's 3 sections of 25 people. 75 people are going to be attending liberal arts math classes. 100 students are enrolled in French 101. Now, does that mean that a total of 175 people are either in French 101 or liberal arts math? Well, that's only true if they're mutually exclusive, only true if they're disjoint. But the fact of the matter is we're going to have 8 students are in both. 8 students enrolled in both liberal arts math and French 101. So they're counted twice. So if L is the event in liberal arts math, and F is the event that they're in French 101, or the set French 101, what are the numbers of either being liberal arts math or in French? That's the number in liberal arts math plus the number in French minus the overlap, minus the number in liberal arts math and French. That gives me 100 plus 75 minus 8. Because the overlap's been counted twice. 100 plus 75 minus 8 gives us, what is that? Total of 167. And we could certainly draw a Venn diagram that describes that, right? If we want to draw a Venn diagram with numbers to sort of show how that works, universal set may be all students at the university. Here's L. Here's F. We just found 8 were in both. There were a total of 100 in French, so 92 must be here. There were a total of 75 in liberal arts math, so 75 minus 8 would have to be 67. So if I'm interested in the number of L union F, I could add those 3 together, 67 plus 8 plus 92. What does that give me? A total of 167, which makes me happy. That's what I had before. And then whoever is in neither liberal arts math nor in French would be in outer space, out in the universal set, outside those 2 sets. And that will conclude this lesson.